So that leads us into changes in matter. We've got properties, and then we have changes, and they're kind of linked together. And how we decide if it's a physical or a chemical change is, again, we're looking at what's happening to the particles, the atoms and the molecules. In a physical change, the matter will change appearance, but the composition stays the same. And this physical appearance change can be pretty dramatic, but we have to think about what's going on with the particles. When ice melts, think of a really fantastic, huge ice sculpture at somebody's wedding, right? And later, it's just a puddle of water on the concrete. Has it changed? It's not the same shape as it was. It was a solid. Now it's a liquid. It was shaped like a swan, and now it's flat, a big puddle. It has changed, but what happened to the particles? They're still water, aren't they? They just went from a solid to a liquid. That's a physical change. In a chemical change, the matter does change its composition. If you have copper, sometimes people will put just decorative, a copper roof on part of their house. And it starts out all shiny like a penny, right? And then as it rains, will it ever rain again? I hope so. As moisture gets on there, it will turn color, and it'll become kind of green and dull, and we say it has a patina. It's all corroded and dirty is what it is. But it has changed. The outside layer of copper has changed. It's combined with oxygen from the air, and it's become a new substance. That's a chemical change. So in physical changes, these are things like state changes, transformations from one state to another. The fundamental pieces of matter do not change their associations. A physical change just results in a different form of the same substance. If you take a block of wood and you cut it in half, it has changed. The pieces are smaller now, but they're still wood. That's a physical change. In a chemical change, the atoms change their fundamental associations. You get a new substance. The old substance gets destroyed, and then a new substance is created. And so a chemical change really is the same thing as a chemical reaction, and we'll be talking a lot about chemical reactions. So the substances that are present before we have the chemical change are called the reactants, and the substances that are present after the change are called products. And so here's your first introduction in this class to a chemical equation. We start with the reactants, and then there's an arrow pointing in the direction that time is passing and we're going this way, and products are formed. Reactants react to produce products. We're not trying to make this difficult, okay? We're trying to make it as simple as possible. So you start with the reactants, they react with each other, and they produce the products. You have a new substance or new substances. The old substance is gone. It's a chemical change. Some illustrations. A Bic lighter. So if you press on the button without actually turning the flint, you can't see it happen, but the butane will escape. So here we have liquid butane in here, and when you release it, it very quickly evaporates and goes into the gas state. If you didn't actually flick the Bic and ignite the gas, these molecules are the same here as they were here. All they've done is go from a liquid to a gas. So that's a physical change. They're escaping from the lighter, but they haven't changed. If we ignite it, though, and we get a flame here, those butane molecules are now undergoing a chemical change. They're reacting with oxygen in the air, and they're forming carbon dioxide and water. And the particles produced here are not the same as the particles that started out. That's a chemical change. classify each change as chemical or physical. And what you have to think about is what's going on with the particles. So copper metal forming a blue solution when it is dropped into colorless nitric acid. What do you think? That's a chemical change. It's actually a pretty dramatic. You can take a, can't remember if I do this for you guys in lab or not, but you can take a nitric acid. It looks like water, but don't drink it because it doesn't taste good. You can put a penny in there, and the penny will bubble and fizz and produce this nasty brown gas, and the water, it looks like water, the solution will turn this beautiful blue color, and if you wait long enough, you'll realize the penny's gone. I know, right? What happened? It was a chemical change. The copper in the penny reacts with the nitric acid and forms copper nitrate, which is soluble in water and goes into solution and forms that pretty blue color. It's a chemical change. The particles have been changed. So that's a chemical change. How about a train flattening a penny placed on a railroad track? And I do not recommend that you do this, okay? Don't do that. Stay away from the train tracks. Chemical or physical? Physical. If you want to flatten pennies, go to the zoo with 50 cents and put it in the machine and crank it. That's a better idea. Squishing a penny, though, it's still copper. It's just gotten flattened. But you haven't changed what the particles are. You've smushed them into a new shape. It looks different, but the particles are the same. How about ice melting into liquid water? Physical. That's a state change. How about a match igniting a firework? That's a chemical change. Any questions? Mixtures can be separated. You can't separate a compound using a physical change, but you can separate a mixture. Because a mixture has two or more different substances, and they're just mixed together. They're not actually bound or chemically bonded together. So you can separate them based on differences in their physical properties. One method of separating a mixture is by distillation. So if you have a mixture of liquids, and these liquids have different boiling points, perhaps you have alcohol and water mixed together. If you heat them, the substance with the lower boiling point will boil first and will go into the gas state. In this apparatus, we're trapping it and not letting it escape. And we're directing it to come over here and run through this condenser. That's a double-walled tube, and we run cold water through the double wall. So it's really cold. The gas comes in here, cools down, and condenses into a liquid again, and then it drips out over here, and we catch it in the flask. So we can take something like alcohol and water. All the alcohol will evaporate, boil off first, and we can collect it over here, and then we'll be left with the water over there. That's separating a mixture based on differences in physical properties. The temperature at which something boils is a physical property. Another method is filtration. You have probably filtered things in your kitchen. Have you made spaghetti? You did a filtration when you got the spaghetti out of the water. Filtration separates things based on differences in their physical state. So you can separate a solid from a liquid using filtration. Here we're using a filter paper, which is very similar to a coffee filter, and we're pouring this mixture of liquid and solid through the filter paper. The filter paper catches the solid and lets the liquid go through. Some coffee makers are very, very similar to this.